So in this problem we have problem number 7. Jen and Jim started hiking from the same location at the same time. Jen hiked at 4 miles per hour with a bearing of north 20 degrees east, and Jim hiked at 3 miles per hour with a bearing north 12 degrees west. How far apart were they after 2 hours? So the way we solve this one, we have to represent everything graphically first. Translate from math from English to math. So first we draw a system where we represent the north here, the east here, the west, and the south in here. So they're saying that they both started at the same location. So let's start with Jen. They say Jen hiked 4 miles per hour with a bearing of 20 degrees north. So that means from the north, the deviation from the north is 20 degrees, and on that side on the east. So they're saying north 20 degrees east. So we are in the east north, so the deviation is 20 degrees. So we represent it this way, like that. So that's Jen. Now Jim, the other person, Jim hiked at 3 miles per hour with a bearing of 12 degree, so north 12 degree west. So we have to north west, and the deviation is 12 degrees. So from here to here is 12 degrees, like that. And it start hiking, is going from here to here. So this point right here is the departure point, where they both depart from. Departure point. So after 2 hours they reach a certain distance. So this is Jen here after 2 hours, and Jim here. But the problem is that they give us only they give us speed. So they're saying that Jen's speed, so let's call S for speed. So Jen's speed is 4 miles per hour, and Jim's speed is 3 miles per hour. And we know that the time after 2 hours, we know that the total time they were working was 2 hours. So with that we can figure out the distance, because from here to here it is a distance, from here to here is another distance. But we have speed, we don't have the distances, but there is a relationship between speed and distance. This relationship is that the distance is equal to the speed multiplied by the time. So let's find the distance from the departure point to Jen final location. So distance of Jen will be equal to 4, because 4 miles per hour multiplied by its time, 2 hours, which is 8 miles. So from here to here is 8 miles. Now next we have Jim. So Jim distance is the speed is 3 miles per hour. So 3 multiplied by the time, 2 hours, so total is 6 miles. So from here to here is 6 miles. Now the question is, how far apart are Jen and Jim? So what's the distance from here to here? So the question is to figure out what's that distance here. So the way we do it, so this shape looks like a triangle, right? We have two sides and we have this angle right here. Notice that this is 20 degrees, this is 12 degrees. So adding those two angles together, so 20 degrees plus the 12 degrees gives you 32 degrees. So this whole angle here is 32 degrees. So we have two sides, one angle. I can directly think about the law of cosine to find the length that is here. So I represent everything with a triangle. So let me represent everything as a triangle like that. Let me represent. So I'm representing everything. So I know that from here to here is 32 degrees. This is Jim here, this is Jen here, this one is 8, this one is 6. So we can label those sides. So we can call this side here A, can call this one B, and this one C. So we can call this side here small a, this side here small b, and we have this side here small c. So based on the law of sine, we told that c squared, we're looking for this distance here, from distance here. So c squared, small c squared, is equal to a squared plus b squared minus 2ab cosine of c. So c will be equal to the square root of all of that. And I plug the values, so I know that a is 8, so 8 squared plus b squared, 6 squared minus 2 times a, which is 8, 6 cosine of 32 degrees. So I take the calculator and I determine the answer, and it told me to round everything to the nearest tenth. So this is what's gonna be like. So 8 squared plus, I start with the inside, minus 2 times 8 times 6 cosine of 32. I get that, and then I take the square root of my answer, get that, and then math round to 1 decimal place and get 4.3, and 4.3 is my answer. So that's how you find the distance between Jim and